Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, we started the light energy chapter. So as I told you earlier that we are going to make this chapter into 3 parts. As I told you, as I promised you in a previous class, we had uploaded one video and today we are going to have some discussion, and the next class we are going to finish this chapter. Now, before going to start today's class, dear children, before going to see what actually today's agenda, let us recap, let us see what we had discussed. Yes, dear children, so we discussed about light, mirror, reflection, loss of reflection, normal incidence and verification of loss of reflection. Let us recall once again. Dear children, what is a light? So, light is a form of energy which produces sensation of vision in us, and the beauty of light is that, dear children, though light is invisible in nature, which makes the things visible. And what is a mirror here? A smooth and highly polished surface which reflects whole light falling on it is called mirror. And there only we discussed about the plane mirror. Simple. See, whether it is a plane mirror or a spherical mirror, what actually decides that? Yes, that nature of the reflecting surface. If the reflecting surface is a straight or plane, we can call it a plane mirror. If a reflecting surface is curved, then we can call it a spherical mirror. Then you tell me, what is a reflection of light? So dear children, when light incidents on smooth and highly polished surfaces such as mirrors, it bounces back into the same medium. So this phenomena of light is called reflection. So dear children, here reflection is of two types, right? Regular reflection and irregular reflection. In a regular reflection, of course, regular reflection will take place only on smooth surfaces. Irregular reflection will take place on even rough surface only, on rough surface only. Fine, yes. Now, what is the reflection of light? Yes, we have seen that it bouncing back only. The two things are very important. What is the angle of incidence? What is the angle of reflection? Dear children, what is the angle of incidence? The angle between normal and incident ray is called angle of incidence, whereas the angle between normal and a reflected ray is called angle of reflection. Is a point clear? Fine. And then we had discussed about the loss of reflection. So what does first law of reflection state? Yes. So according to the first law of reflection, dear children, incident ray, reflected ray, normal drawn all lie in the same plane at a point of incidence. And the second law is that angle of incidence is always equal to the angle of reflection, irrespective of nature of the surface, whether nature of the surface is smooth or a rough surface, whatever it may be, dear children, angle of incidence is always equal to the angle of reflection. Next, one more important point is that normal incidence. So whenever light incidents normal to the mirror surface, its path is retraced. So in that case, angle of incidence is equal to 0 degrees and angle of reflection also 0 degrees only. So these are the topics which we had discussed. If you have missed or if you want to revise once again, yes, link will be given in the description. Go through that link so that you will have a previous class as it is. Now let us hear today's agenda. Dear children, in a today's class, we will be mainly talking about the image formed by plane mirror. There only we will see for a point object and extended object. Then we will discuss the characteristics of the image formed by plane mirror. Then there only we will see the lateral inversion. Finally, we see the difference between real image and virtual image. So this is these are the topics which we are going to discuss. Okay, are you all ready? Ready? Yes, dear children. So if you are ready means yes, definitely you should have taken already notebook and you should be ready with the pen, so that you can take some important points. And in today's class, the ray diagram is also very important examination point of view. Shall we start, dear children? Yes. So first, as I told you that we are discussing the image formed by plane mirror. So what is that here? Image formed by by plane mirror. Children, what is a plane mirror? The mirror whose reflecting surface is a straight or a plane. Now under this, first we will see for a point object. We will see point object. So what happens when a point object is placed in front of a plane mirror? What kind of image is formed, and what will be its size, and what will be the image distance, object distance, nature? Yes, all these things we are going to cover. Okay, now have some patience and should have even concentration also. Look at it, children. Now we need to take a plane mirror. See, plane mirror you can take horizontally, you can represent even vertically also. For the sake of my convenience, yes, you can do in even exam also. In a textbook they given as a horizontally, but I will take perpendicular. Nothing is wrong. Mirror is mirror only, right? Whether just you can keep it horizontally or vertically, it doesn't make difference. Okay. Look at it, children. So this is, yes, plane mirror. So this is, we know that it is a silvered and with a protected opaque surface, right? Okay. It is a plane mirror. Let us name it as a M and M dash. That's fine. Now let us take, children, here one point object O is placed. Point object O is placed. Here some terms are very important. The distance between mirror and object. The distance between mirror and object is called object distance, and we will represent with the letter U. So let me write here. Dear children, what is a U here? U is a object distance. U is called here object distance. And dear children, from this object, light rays will get spread in all directions, 360 degrees. 360 degrees. But here we are very much interested about the light rays which are traveling towards the mirror. Why? Because those light rays only will form an image. The light rays which are going in this direction or in this direction, they do not form image. So towards the mirror also, lakhs of light rays will be moving. But the question is that how many light rays should we consider? Means some will tell 100, some may tell 1000, some may tell 5000, some may tell 10. Okay, that's fine. Maximum means can be any extent. But here we should understand. So how many minimum number of light rays are required to get an image, to form an image, to draw a ray diagram? Dear children, the minimum number of light rays are 2. So the minimum number of, so I can say that 2 incident light rays are enough actually to get the image. But if you want, you can take more than that also. So as the number of incident light rays are increasing, dear children, the complication level increase. Otherwise, there won't be any difference. With the 2 light rays, whatever the image size, image nature you are getting, with the 2 lakhs light rays also you get the same. As in both cases it is same, let us go with the 2 light rays only, so that the situation also will become very simple, so that we can understand very easy manner also. Okay, fine. So from this, we are taking one light ray. Yes, one light ray I am taking which is incidenting normal to the mirror like this. Exactly normal. Let us say this is the first light ray. First light ray incidenting normal to surface. And one more light ray incidenting. This is second light ray. And the children, even if you can see in a textbook, they have taken 2 such kind of light rays only. But okay, but one important point, when you take one normal light ray, one light ray which is incident normal to the plane mirror, diagram will become very easy. You can do this in exam also, you will get a full marks. Okay, fine. Now, already we discussed, whenever light ray is incidenting normal to the plane mirror, its path is retraced back. So, this light ray bounces back like this only. This light ray bounces back. So, first light ray is going like this and coming back. So, it bounces back. I can say that. Okay, na? So, let me put a 1 dash. 1 dash means what? 1 is the incident ray, 1 dash is the reflected ray. So, incident ray is going like this only, reflected ray also going like this only, coming back. But when you see from here, this reflected ray appears as if it is coming from the back, somewhere else. You feel that, yes, this reflected ray is coming from behind the mirror. You feel actually it is a behind the mirror. Okay, na? So, here is, let me just, ting, ting, ting. Okay, that's fine. Now, this second light ray, here, children, for example, if this light ray is incidenting with the some theta angle. By obeying the laws of reflection, with the same angle it should get reflected. Yes, it is getting reflected. Sorry, excuse me. It should get reflected. Yes, with the same angle it must get reflected. Let me write the 2 dash. So 2 dash is what actually? Reflected ray of second light ray. Now if you can see, this light ray, first light ray is going like this, second light ray is going like this. Now do you think that after reflection these two light rays are meeting? No. Dear children, here we have two conditions. After reflection, either light rays must meet. Means it is not mandatory, sorry to use a must word. So light rays may meet or may not meet. If light rays are meeting means what? After reflection, if the light rays are meeting, then what we can say as a result, the image is formed called real image. So real image is formed by actual meeting of the reflected rays. But here after reflection, light rays are not meeting. Dear children, whenever light rays are not meeting, we have to extend back. Let me draw this properly, ma. Let me draw this, excuse me. See, you means you have a scale pencil, I think better way you can make it. Okay, yes, with the same angle. Now, let us extend this back. That's it. Okay, now the point where the light rays are appearing to meet is the image position. Try to understand. Why we produced back? Because the light rays are not meeting. Okay, fine. So children, now look at here. Let us say this point is A. So here OA is called what actually? OA is called object distance. And the distance between mirror and the image is called image distance. So that is AI. Okay, so okay, it is a AI. AI is V. So V is what children? It's the image distance. Image distance. So, and look at here first. So this is how actually image of this point object is formed here. Here two conclusions we can make. First conclusion, the image form, the nature of the image form in this case is a virtual image. You make it one doubt. Sir, how can you say that the image form is virtual? The children, already I told you, after reflection if the light rays are meeting, then that will be the real image. After reflection if the light rays are not meeting, if they appear to meet when they are produced back, then those light rays will give you virtual image. In this case, do you know these light rays are meeting? No. So when they are produced back, they are appearing to meet. So hence the image so formed is a virtual image only. So here I can say that the first conclusion, the image formed is virtual. Great. Second one, if you can see, U is equal to V, which means what here? In the case of plane mirror, object distance equal to image distance. Object distance equal to image distance. For suppose, if you are standing in front of a mirror at a distance of 10 meters, then your image is formed 10 meters behind the mirror. Remember that, dear children, virtual image is always found behind the mirror, but whereas real images are found in front of the mirror. Okay, fine. So this is how actually image is found by the plane mirror, and we have seen for a point object. Now we will see for a extended object. What is that? Extended. We will see for extended object, so that finally we will get all conclusions regarding the characteristics of the image formed by what is plane mirror. Okay, now fine. Now same manner I will take yes. The children already told you can keep mirror horizontally also, nothing happens. Okay, fine. Now so it is M dash is a mirror. Okay, now in front of this I placed one object. Extend object means bigger object I placed. Now let me tell you, dear children, so just follow my instructions, the method how I am going to do it, then you also will get the best ray diagram. Okay, fine. Now this is a head. Okay, it's a tail. From head you can take one light ray which is moving normal to the mirror. Okay. From tail also you can take one light ray moving normal to mirror. Okay. So let us see the first light ray, it is second light ray. Now can I see that whenever light is incident normal to the mirror children, it bounces back, means its path is retraced. Okay. Yes, so this light ray bounces back like this only, as we know. It is a 1 dash. 1 dash means what? This is a reflected ray of this light ray. And here also light will get bounces back. Light will get reflected back. So it is a 2 dash. But these two light rays appears as if they are coming from the behind the mirror. So these two light rays appear as if they are coming from the behind the mirror. Okay, that's fine. Now let us take two more light rays. Okay, here let us extend the mirror, like a big mirror. Okay, this is third light ray, and take one more light ray. Yes, it is the fourth light ray. 4 light rays we have taken for extended object. The children, and these 3 and 4 are not a normal incidents. So by following the laws of reflection, it gets reflected. So this is 3 dash, which means what? Reflected ray of this third light ray. Reflected ray of what is children? So it is a third light ray. Okay, and this also gets reflected. It is a 4 dash. Okay, here 3. Why I give a number? So that you should get a clarity. You should not have a confusion. Now dear children, so here what is happening here? Again these light rays are not meeting after reflection. Then we have to produce back. So this light ray just try to produce back. Okay, and this light ray also you try to produce back. Fine. Now this, in between these 2 points, image is formed. Image is formed. For example, if it is A, B, then this image will be A dash, B dash, A dash, B dash. For example, this height of the AB is a, let us say, HO. The children here, HO is a object height. Let HO is a object height. Okay, na? Then HI is the image height. HI is the image height. These terms are very important, children. So then what about UMA? Object distance. The distance between mirror and object is called object distance, whereas the distance between mirror and the image is called image distance. Now you tell me, dear children, in this case also, is it real image or virtual image? 100% is virtual image only, because after reflection light rays are not meeting. Then what are we doing? We are producing the reflected rays back, so they are appearing to meet. So virtual image. So in these two, with these two cases, very clear that plane mirror always forms virtual image. I repeat once, plane mirror always forms virtual image. All virtual images are by default erect. So plane mirror always forms virtual and erect image. First point, first characteristic of the image. Second one, yes, object distance always equal to image distance. Okay, fine. Third one, dear children, object height and image height always equal. Means image height is always equal to object height. See, for suppose, as I told you that if you are standing in front of the mirror at 10 meters distance, your image is formed 10 meters behind the mirror. That is fine. And if my height, for example, my height is 5.3 feet, then my image height also 5.3 means 5.3 feet only. Okay, so image height is always equal to object height. And then one more thing we can do, children. For suppose here a person is standing, let us say, so that it is his head, hand. Okay, for us it is left hand, it is a right hand, let us say that. This is how the person is standing. And here also person image is formed. Let us say it is a head, it is a hand, it is a hand, here is a leg, here is a leg. But here it will be right hand, and this will be left hand. Okay, this also, children, you might have observed many times, which means what? This left hand appears as a right right hand appears as a left. So if you are standing in front of mirror, if you can move your right hand, but in that mirror it appears as if you are moving your left hand. But if you move your left hand, in that it appears as if you are moving your right hand. Means right of the object appears as a left, left of the object appears as a right. So this phenomena only we can call it a lateral inversion. Yes, very important. So fourth characteristic, the image from the plane mirror is a lateral inversion. What is that, children? Lateral inversion. Based on this, we have a question. We will see that lateral inversion. Very, very, very important. So this is how actually this is the image formed by plane mirror and a characteristics. Children, four very, very important characteristics. Four characteristics. So what are the characteristics of the image formed by plane mirror? First one, it forms virtual and erect image. Second one, image distance is always equal to object distance. Third one, image height is always equal to the object height. Fourth one, image is laterally inverted. Now we will try to have a little bit depth discussion about a lateral inversion. We may have questions also. Are you ready? First copy this. First copy this. Be careful, mo. Be careful. Okay. Copied. Copied or copying? Yeah, copying, sir. Okay, na? So good, 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 good. You are really such a wonderful student, ma. Okay. Can I erase? Okay. I'll erase this side so that you can copy that one. Okay. And also you can pause the video and you can copy it. That's it. Okay. Fine. So lateral inversion only, little bit depth we will discuss under this only. Lateral inversion. Lateral inversion. Lateral inversion. Okay. So as I told you that, so right of the object appears as a left and left of the object appears as a right. That phenomenon of light only we can call as a lateral. That is one of the important characteristics of the image formed by plane mirror. Okay. Now the thing is that in English alphabets 26, how many letters will show lateral inversion? Come on children, just pause the video and tell me how many number of letters will show lateral inversion. Okay, got it? Okay now? So I want you to comment that answer. Hope did? Fine. Look at here. The children, for suppose here is y, z. I think some of you are thinking, sir, we came here to learn physics and we expected that you will teach physics and we learn. But what is you are teaching alphabets? I am teaching alphabets only. But how they are going to behave, how they are going to appear when you place in front of plane mirror. These are very important and questions can be expected in the exam. Look at it, children. So A appears like A only behind the mirror. But B appears, yes. C appears like this. D appears like this. E appears like this. F appears like this, G appears like this, H, H, I, J, J, K, K, L, M, so N, no, sorry, N, O, P appears like this, Q, R, S, T, U, V, W, X, Y, Z. So if you can see, A is not showing the lateral inversion, H is not showing, I is not showing, M is not showing, O is not showing, T is not showing, U, V, W, X, Y. These letters are not showing the lateral inversion, which means what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 letters are not showing the lateral inversion, whereas 15 letters are showing the lateral inversion. 15 letters are showing the lateral inversion. Then you may get one doubt, sir, do they ask questions like this? No, they won't ask you the question like this. They may ask question like this. Can I erase this side? Okay. So they may give you one word, dear children. They will ask you how does it appear in front of a plane mirror. In front of plane mirror. Look at here. For example, here is a plane mirror. Let me write one of the greatest person name. Okay, na? N A R E, oh my god, S H. Who is the greatest person? Yay, it's me only. That's what, sir, you are praising yourself, you are making your own self dabba. What I should do, dear children? Society and people are not recognizing me, so I have to recognize myself. Okay, now it's self-satisfaction. That's it. Okay. Now, how does this nourish word appears in that? So some of you, if I am not wrong, you will write like this. Sir, N means like this, sir. Okay, great children. Ting, 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 N. A means A only. R means yes. E means like this. S means like this. H means like this. Some of you might have thought like this, but it is wrong. Wrong. You may get out, sir. Why it is wrong, sir? As you said, we followed. Yes, my dear children. But lateral inversion means what here? Left appears right, right appears left. You are thinking about only a particular letter position. But when you consider this entire word, this is left, this is right. Yes or no? So, this entire word also should get laterally inverted. Each and every letter should get laterally inverted. At the same time, entire word also means from here it will be H S E R A next N. Here is N. That's it. Sorry. Here is N. So this is how we should write. And if you can see the word ambulance, how it is written on the ambulance, dear children, it is written in this format only, so that whenever you can see that rear view mirror, it appears in a proper way. So in exam, any word might be given. I repeat once, where many students will do mistake, they'll do every letter like they'll think about the lateral inversion, but entire word also should get laterally inverted. Okay, fine. So this is about actually characteristics of the image formed by the plane mirror. What are the characteristics, dear children? Image is virtual and erect. Image distance is always equal to the object distance. Image height is always equal to the object height, and image is laterally inverted. Now, the last I can say topic for this session is the difference between real image, and here is virtual image. Real image and virtual image. Which, as I told you that real image is formed. It is formed by actual meeting of reflected rays. By actual meeting of reflected rays. But virtual image is formed when reflected rays are produced back. When reflected rays are produced back, then they appear to meet. Here actually they will meet, here appear to meet. Okay, fine. And a real image is formed in front of the mirror. Real image is formed in not font, in front of the mirror. Real image is formed in front of the mirror, whereas virtual image is formed behind the mirror. It is formed behind the mirror. And the third one is that, the children, real image can be obtained on the screen. Because the light rays are meeting, right? Obtained on the screen, whereas virtual image can't be obtained in the screen. Can't be obtained on the screen. And the fourth one, real images are inverted. Whereas virtual images are erect. That's it. So dear children, so these are the differences between real image and virtual image. So with this topic, today's session is concluded. Okay. So the small, whatever is a little bit a small topic is there, that we'll try to cover in a next class. So children, today what we discussed, only today is only one point, only one agenda is only one point, like it's like a image formed by a plane mirror and the characteristics of the image. There we discussed about the lateral inversion, and finally we could conclude about the difference between the real image and a virtual image. Okay children, thank you so much, all the very best.